Hello, I'm gonna go over how I made this small linear variable DC power supply. It's based on the LM317 adjustable voltage regulator from Texas Instruments. I wanted to build this to figure out how to make a simple power supply I could use to help prototype other circuits. The main circuit itself is fairly simple, and I added a few extra components for more features. This is the schematic for the circuit, and I'll go over the rest of it in a bit, but you can see here at the heart of the project is the LM317. Its main feature is the ability to be adjusted while active to produce different output voltages, which is the main capability that I wanted this project to have. And we can take a look at the data sheet for some more design information. So this is the main circuit that I based the project on. There are a couple of things that I need to consider. First of all, I wanted to have a max output of 12 volts. And you can see here that the output voltage depends on R1 and R2, as shown right here. Um, and R2 can be set to a fixed value, or it can be a variable resistance depending on the application. And the output voltage itself is based on equation 1 here in the data sheet. And you can see that it is primarily based on the values of R1 and R2. Um, and as it says here, this chunk of the equation is pretty negligible based on there being about 50 microamps for the I adjust or the current here in the equation. So after running the calculation with that equation and determining what I would need to meet my requirement of 12 volts for V out, I decided to use a 240 ohm resistor for R1, like in the datasheet schematic, and then a 10K potentiometer for R2. I initially used one of the larger potentiometers. I think they're like audio ones, but it seemed to have a nonlinear change in resistance, which was making a nonlinear change in the output voltage when prototyping. So I switched to just one of the like a small 10K trim pot, and that worked a lot better. The schematic here is based on that typical application schematic shown in the datasheet under section 9.2. It has a few small modifications, which I'll go over soon. But the main components here that work with the LM317 are R1 and R2, which I talked about, and then CI or C input, which is just a filter capacitor, and CO or C output, which helps the output voltage and like the transient response of the circuit. And then C adjust here, which helps output the output voltage stability and voltage ripple rejection for the LM317. And then D1 and D2 are protection diodes that provide low impedance paths for C out and C adjust discharge respectively. These components and their design considerations are under the next section, so like section 9.2.1 in the design requirement section of the datasheet. And so the extras I added were the power switch over here, which is um, pretty self-explanatory, and then R4 here connected to the power switch to safely discharge the circuit on a path to ground. And then I also added R3 and D3, which is just a power on light. And then the last thing I added was a voltmeter to display the output voltage. So that's it for the design portion of the project, and now I'll go over some of the physical components and then we'll get into the build. These are all the components that I needed for this circuit, and I did have most of them on hand, but I needed to purchase the voltmeter and power jack. So with that out of the way, it's time to finally get into the build. I wanted to use a small piece of spare perf board that came from a past project. The idea was to make the supply as small as possible, and to reduce the overall size, I'm using a 12 volt wall adapter, but I'd like to create my own step down transformer circuit in the future. I cleaned the perf board up a little bit to make sure that it wasn't going to catch or snag on anything later. The area at the edge of the board worked well for the power jack I had, and I decided to put the jack as close to the outer edge as possible. After measuring the pins on the power jack and marking where they would go on the board, I was able to drill the mounting holes. This process was a little weird because of the angle and size of each of the pins on the power jack, so it was more like the mounting was actually done via soldering it to the rest of the circuit rather than actually mounting it to the board itself. This was a bit harder than expected on the smaller board as I didn't have a great setup for drilling, but it seemed to work out alright. After lots of thinking about how to lay out the components, and after a couple of restarts, I was able to lay out the components in a compact way. Even after all that planning, I did still need to move some components around to make sure that they were in the correct places for soldering. To try to keep everything in the board while soldering, I like to bend the legs of each component, and I also added some painter's tape to the top to prevent things like the switch from falling out. My method sort of made a mess of the legs and didn't help too much with components falling out, but it's a learning process. I started soldering the components in by securing at least one leg of each component. That way I could check to make sure each component was securely attached and as flush with the board as I could get it. At this point, I unfortunately ran out of my old trusty solder and opened up a fresh new spool that was so cheap it would turn into a weird flaky paste if it was reheated a second time. This significantly slowed down the build process and made my solder joints terrible. It may have just been me, but this is a small board I did for another system right before working on this project, so I'm going to blame the solder quality this time. Alright, here's the supply after finishing up the soldering. As you can see, the solder bridges are pretty bad, and I had to run my soldering iron pretty hot to get it to even bridge, which melted the outer sheathing of some of the wires. But hey, looks are for nothing if it doesn't work, so the next thing I did was a power on test just to make sure the LED powered up and nothing caught on fire. And there we go, the LED powered right on, not much to it. Next, I tested the output using a multimeter and the voltmeter I would be connecting to the circuit later. The accuracy was off in the thousands of a volt range, but there is a trim pot built into the voltmeter to tune it. I also tested changing the voltage with the trim pot that is in R2's place, and here you can see that the maximum voltage is actually 11 volts and not 12, and that the minimum that shows up on the voltmeter is about 2.4 volts. I didn't pay enough attention when ordering the voltmeter, and it has a cutoff voltage due to being powered by the same voltage it is sensing. And there's a more expensive version of this voltmeter on Adafruit, but this works just fine for me, although it's one of the things that I'd improve if I made another power supply. I printed a mount to add the voltmeter to the side of the perf board so that it wouldn't take up space on the main face of the board and could still be compact. I used some laptop screws to secure the voltmeter to the mount, although they were slightly too small, so it was a tight fit and one of them stripped initially. I think the mount worked pretty well, and I was able to just slide it onto the side of the perf board. I finished up by soldering the voltmeter to the output of the circuit. And this is the final result. I think it turned out pretty well, and the main feature of this project is the variable output and voltage display. There are definitely some things I could have improved or done differently, and better solder would have helped as well. If I were to make another version of this project or a different power supply, I would have obtained a voltmeter that could read down to 0 volts and maintain a constant brightness, and work on playing out my layout a bit better so that it was cleaner and more compact overall. Potentially using a printed circuit board and maybe surface mount parts. So that's it for this one. If you liked what you see, go ahead and leave a like and subscribe. And if you have any questions or want to discuss the project, go ahead and leave a comment down below. Other than that, thanks for watching. Bye!